So for 43, here's the picture in the book. And what do you have? All of the events in here are equally likely to occur. It says this thing, you know, the word problem isn't important, but it happens at random. So everything between 1 and 5 seconds is equally likely to occur. So the question is, how tall, what's the height of this density curve? Well, we told you up here, the area is 1. So if the area is 1 and the base is 4, what do you multiply 4 by to give you 1? The height must be 25 hundredths. Okay? So the dimensions of this density curve, it has a base of 4 and a height of 25 hundredths, which makes this area in here, this shaded, I don't know what color that is, but that has an area of 1. Okay, so that was pretty straightforward. But B is confusing because B asks you to say, what percent of the time will be more than 3.5 seconds? So 3.75. So we're here. There's 3.75 seconds. More than that. Okay? So in order to make this easier to understand, I shifted everything. See, this graph starts at 1. It'd be easier to do this problem if it started at 0. So if I shift everything 1 to the left, then I'm saying 2.75 more than that, and then the base would just go from 0 to 4 instead of 5 to 1. So at 2.75, if we only went to 4, right, 2.75 is 11/4. This 4 in the denominator I brought out, made it 1/4 here, so that's 11/16 of the curve. 11/16 of the curve is to the left of 3.75. That's 68.75%. More than that would be 1 take away that, which would be 0.3125. So what's confusing, I get it, because I remember doing this problem for the first time last year. What's confusing is the graph begins at 1 and not at 0. But if you just look at this, does this make sense? If it says more than 3.75, you certainly have less than half the area is to the right of that. So does your numeracy, does your answer make sense? And our answer is less than a half. C asks, the subject at the 38th percentile was at 2.52 seconds. No, that's not. It asks you, what is the 38th percentile? So they're saying, who beat 38% of the test take, of the people that did this? So 38% is less than half. So it has to be, ready? 25% would be there. So it has to be between 2 and 3, the 38th percentile. So what did I do? I said 38th percentile times 4. Why 4? Because that's the width of this box. 38% times 4 takes you to 1.52. But since you started at 1, not at 0, do the shift, and that takes you to 2.52, and that would capture 38% of the area of the curve is to the left of the 2.52. Now, the line has no dimension, so you don't have to worry about landing on the line. We're saying at this 2.52, 38% of the curve is to the left and 62% of the curve is to the right. Okay? Now, 47, see, you'll deal with, this is, you'll get questions on density curves, but not to the extent that you'll get questions on the standard normal curve. That's the primary focus of the course. So we go to 47, and here's a picture, right? We showed you how we got the picture. I just did a graph link of problem number, or of what we had in the calculator. So what happened is, I put the standardized scores underneath here. 0, you're right at the center. 1 to the right, 1 to the left. And we counted out 3 each way. You don't need this line, like where it says mu, sigma 2, sigma 3, sigma. You don't need that. But we're just trying to, begin to show you where this stuff is. So they're telling you the mean of these potato chips is 9 and 12 hundredths. So that's under 0 standard deviations. That's what the mean is. If you buy a bag of these potato chips, it's going to say 9 ounces on it. But the expected value in the bag would be 9 and 12 hundredths. Now think about why that is. If the factory shot for 9, the advertised amount for the center, then 50% of the customers would get less potato chips than they were anticipating, and you would lose customers. You would have complaints. So they advertised down here. They advertised 9, but they actually build this model to have more than 9 in there, because at 9, ready, you're still going to have some people that get less than 9 ounces of potato chips. So essentially what they're going to do is work backwards for when they decide to be, an acceptable error. If you say, we don't want any unhappy customers, you spend too much money. You make this 9 1/4, but then, you'd be putting more potato chips in there than you're advertising, and you'd have all happy customers. But if you went to the competitors and they were putting this much in there and you were putting 9 1/4, they could afford to sell their potato chips for less, and you lose customers that way. So the issue is, all we're concerned about is these numbers down here aligning with the standard scores. Okay? That's it. All you're doing is drawing the curve, marking up the z-scores, the standardized scores under the notches, and then below them putting the data points, which are the potato chip bags, how much they weigh. So we're going to go back to 45, which you didn't do. I just want to show this to you. There's 2 pictures. We don't really care about picture B. And they're talking about mean, median, and mode. And you learn this, at ETR. The mode is the data point that repeats the most. So this thing peaks at point A. But what about B and C? Which one is the mean and which one's the median? So we talked about this last week. The shape of this graph is skewed right. That's where the tail is. So when these points out here are affecting the mean, because the mean is sensitive to outliers. The median is resistant. So when this skewness will drag the mean to the right. So C necessarily represents the mean, and B would be the median. Now this picture is not as important, but in this picture it's symmetric. Okay, so A and C are the modes. And because it's symmetric, the mean and median would map onto each other at B. Okay? So